Hello friends and welcome. So here we are outside and we're looking at kangaroos sort of enjoying the morning sun and a bit of feed from our lawn. But it is time for my new top 5 of indirectly heated high transconductance tube with the intention to driving a tube like the 300B and Type 50. So let's go inside and talk about that. Hello Rainy, hello. So here we are, and now this video is really a continuation of my a video that I produced about 2, maybe 3 years ago, where I had a top 8 of indirectly heated tubes and I had compared them. Now what I did this time is I took the best 3 out of that test and I added 2 new tubes that have come into my possession and applied a much more rigorous process, designed them in LTSpice, highly controlled circuit, then optimized, and at least listened to the whole amp for a day. And then in the end I went through the 5 tubes and then I went back to the first tube just to make sure I had a really nice reference of how the sound, how those tubes sound in comparisons to each other. The big difference is also this has been a quite controlled test, reasonably optimized, although not to the final degree, but I think enough to come to a decent conclusion how these tubes sound in comparison to each other. Now the whole top 5 has completely changed. Although I must say that perhaps the differences between the tubes is much less than it was last time. And I think as you learn to more optimize the performance of your topology, choose the right tubes for that topology, that you find that optimized use of the right tube in the right places gives you less differences than I think is generally portrayed. So what I'm going to do in this video now, this video consists out of this introduction. In part 2 I will give you the exact circuitry that I used and the topology, some of the special aspects about that topology. In part 3 I'm going to present to you the top 5. I'm going to discuss each of the 5 tubes and I will rank them in 2 dimensions, and both are subjective, but I think they'll give you, and I'll explain a little bit what I think for which systems, which tubes are the best suitable. So that's why I'm going to rank them in 2 dimensions. I'll also give you my own preference. And then finally I'm going to give you a conclusion, and I'm also give you, for the 2 winners of this test, I'm going to give you what I think is what you should consider as or what I would consider as the optimization path to getting the most out of those tubes, because for the 2 winners I see very different optimization paths. So that's this introduction. Let's now go to the schematic. So here we are. So the approach that I took for each of these amps, because I just moved away from my amp platform that I used to develop everything, but this was the schematic, and what I did for each tube is first simulate it in LTSpice, just have a look at what I can expect with the harmonic spectrum and the operating point. General, of course, high transconductance tubes. Also, given that we need headroom, are best run probably what is called high and cold. So unlike DHTs, which we probably sound best low and hot, so with a lower voltage but lots of current, with the driver tubes I took the other approach. I ran them high and cold, so with relatively lower milliamps, but so that but with highest voltage, sometimes even over the specs, but at a low current, so it will be fine. And then that way I get the maximum headroom, which all of the tubes tested basically have the issue that the headroom is not fantastic when driving a 300B or a Type 50. Not much special about this circuit, but I want to give you, just to be complete, two remarkable points probably. I'm using a couple of remarkable points in this test setup. Number one, I'm using filament bias on the driver tube. So I'm using a Rod-Coleman regulator here, and also for the Type 50. So it was run on the DC, regulated with a current source. This was the same for all tubes. However, of course, what this has done is that the bias resistor is very small. I'm also losing a bypass cap. Now what I did do is use ultrapath in each configuration. So I didn't bypass the cathode resistor here. I just made sure that the loop here is very small and doesn't run through the power supply caps. So this is used for filtering. This is for the signal. So it's the shortest return path possible. Other notable thing is, so that's filament bias and ultrapath. The last special thing about this is that this coupling, unlike capacitor coupling or normal interstage coupling, what I did is retain the phase between these two tubes, so they're not in counter phase. And the advantage is, well, unless you're trying to chase a meaningless number like THD, I didn't use harmonic cancelling between the stages. So what can happen is that the even harmonics can get cancelled. Just like in a push-pull amp, if you choose your tubes and operating points well, you can actually cancel the even harmonics. And then your amp will almost sound like a push-pull amplifier, because the harmonic spectrum will look as a thing. But the problem is with harmonic cancelling is that it creates odd order harmonics. So your second and fourth will go down, but your third and fifth and so on will go up. And the problem is you're then swapping music consonant harmonics, because it's very natural for an instrument to also have the double and the 4 times the frequency of the fundamental, and you're cancelling those natural harmonics, but you're creating the dissonant harmonics, so the third and the fifth. So that's not very useful. Although the fifth has of course the effect that you actually hear that it seems that the music is louder. That's what the fifth harmonic gives you. So I didn't use harmonic cancelling. That meant that the second harmonic of this tube would just be added up with the second harmonic of that tube. But what I have seen is that the harmonic spectrum just generally, being a 2-stage amp, just drops off really quickly. Now there was one tube in the test that actually had a bit of high levels of second harmonic distortion beyond what the others had. However, that tube also had the advantage of having very low higher order products. So yes, it was a bit high in second, but the rest just dropped off like a bomb, and that was actually very nice. So that's the circuit used in this topology. Approach very similar. I tested the amp in LTSpice, built it, then listened to it and optimized the operating point of the driver to as nice as I could get it. And so that's what this test is based on. So let's now get into the 5 tubes. Yeah, so here we are with the 5 tubes that I tested. So let's get through them. First of all, one note. This test is by no means complete. It is also pertaining to high gain tubes. So all these tubes have 40 to 55 times gain in the actual circuit. I didn't use, for example, the EL33. It's a tube which I dearly love. It only has 20 times amplification. And with a step-up transformer, of course, you get the same effect. But it's a little bit outside this scope of this comparison. Now I will also put on screen some really worthy candidates that have been used by other people, or that are perhaps on my radar but a bit too rare or expensive, or because they have been successfully used in well-known amp designs. So those are also of consideration. So I'll have them in screen now. Those tubes, please consider them, because this test is by no means complete. It's just these are reasonably affordable tubes that are reasonably well available, that do the job really well, and how well you will now see. So let's just quickly talk through them. So this is the tube that really set this whole thing off, the 6S3P EV. Now some people use this for tube phono stages because it's a very low noise, high gain, reasonably high gain tube. When I implemented this tube for the first time, I was just really impressed by its dynamics, with its clarity, and the dynamics were of such a scale that I didn't feel that I needed a differential amp to get the dynamics. Then 6X9PE, this is a tube that ended up high for classical music in the last test, like probably then in second position if you like classical music, else it ended up as third in the last test. This is basically the pentode brother, I think, of this tube. They're highly similar in specs and operating point. Third tube is the second tube out of the last test. Now Millie has joined me, so she's casting big shadows here over it, and she likes to be in the center of attention, don't she? So here, third tube that I tested was the E280F Philips. Let's just move this out of the way. This is the Philips special quality tube. Ended up second in the last test. Not so good in this one. Then here, 6S45P, the winner of the last test. Very powerful tube. And thanks for standing in the sunlight, Millie. But not ending up at the top this time. And then finally we got the darling of the whole tube collection, because it's used in the darling amp, the 8532W, which is unlike these, which are all novel type bass, so 9-pin. This is a 7-pin, so it's a miniature tube. However, not miniature in its sound. So those were the tube tested, and now I'm going to put them into a top 5. So here we are. This is my two-dimensional top 5. So just to explain you the dimensions that we got here. Here we got resolution and clarity. In some ways you could also say dynamics. In some ways it sort of seems to be related. And then here we got the naturalness of the sound. Now I know both of these have been completely subjectively, because there is no measure for resolution, and there is also no measure for naturalness of the sound. So as we go up, more clarity. As we go up, more natural. Here I would say it's more fake contrast and digital sounding. Here it's more analog and DHT sounding, if you will. And what I have generally noticed is that the higher transconductance, the more contoured the detail is. So it's like detail as apart from others, not as a natural whole. And while this seems very impressive, and that was certainly the case with, for example, here my first tube, the 6S3P, I was so impressed, but after a day or two it really started to annoy me. And I tried to optimize it, but we'll talk about this in the end conclusion, how to optimize these amps. But anyway, the results. The Philips E280F. So this is completely on the unnatural scale. It sounded very hi-fi, a bit brash and overly focused on the highs, I would say. Now this is of course a wideband amplifier. I don't think audio was its design goal. Very high resolution, but this was probably the most disappointing tube of the test. I don't know why it came out high the last time, but I couldn't really work with it. Then let's go here, the 6S45P EV. So this was the tube that I used last time with Grey and was the winner of the test. very powerful tube, high gain, very low plate resistance. So this one is far more capable of, for example, being direct coupled to a driver because of its low plate resistance. And because of that, even if the grid drops in resistance, this tube will sort of behave really well. So it will behave well under overload conditions. However, it was highly contoured to music. It was very very precise, very dynamic, very contour detailed, but much more pleasurable than the E2 ATF, like on a whole new level. Much more, I wouldn't say that it was that natural, because I found it to be a really I don't know. It's not like normal natural sound reproduction as you hear it in real life. It is a reproduced sound, a very literal reproduced sound. Not bad, a lot of people would prefer this tube. It is a very popular tube. However, I scale it on not sounding that natural. It was by far the most revealing in terms of details, but in the manner that I just said. So yeah, very impressive tubes. Now this tube I wouldn't normally recommend starting with out of this whole 5, but if you have a system that is a low efficiency, is maybe not, is a bit soft and spongy or something, and I think that's what I had relatively to what I have now, this tube can actually sort of bring your system to life. So you're not then tackling your problems head on by actually getting better speakers, but what you're doing is you're making your system work, and then this tube can work really well for you. Then the tube that started all, the 6S3P. So I ranked this nearly as high in resolution as the other two. However, I would, because it had very high detailed sound, see-through quality, very nice. Even I would say it pulled some color out of the music. You know, it displayed different gradations of color in the music really nicely. But yeah, so eventually it sort of annoyed me a little bit, but it was very minor. And the naturalness is pretty good. So because of these small differences, if you're interested in this kind of sound or a highly dynamic sound that has all the detail, and you like that kind of touchy music, this I would go first with this tube before moving to that one. It's also a lot less well known and probably available at a much better price. I got a stash of them, but anyway, interesting candidate. Then we move to the Darling amp driver. So this is the 8532W. I saw that Janos from Real World Audio just has actually now moved to driving an 807. So basically what I did is make a Type 50 Darling. With the only difference, another difference of course, that I use in-phase interstage coupling. Very nice tube. Very natural sounding. I can see also why in my previous amp, that was this tube driving a differential pair of 4 P1Ls, directly heated tube. Why I didn't miss having a DHT in my chain, because it almost approaches the DHT, but a tube like say the Type 26. However, I heard a very particular thing in the sound, and that was that there was a certain veil of the music, and that veil was very consistent. So it changes the sound somewhat, and it gives sort of a warm factor, and it might actually be the second harmonic distortion, which is high with this tube. But the higher order products are very low, so it is still a very clean, but there's an almost tangible veil moving from that tube, comparing these two, because these were in the first and the last of the tube, and I swapped from this one to this one at the end. I noticed that that veil is very tangible, but it works with the music. It's not very dissonant, that veil. It doesn't really hide the details, it just modifies the sound a little bit. But in a very pleasurable way. And I also noticed that the bass just has a very nice quality, maybe because of the distortion, I don't know. But it just worked. And because it's so consistent, I didn't find it objectable. So, however, when I later switched to IDHTs, of course, they didn't have that issue. But so for very different reasons, yes, this tube, so it has a slight, it doesn't have the sheer see-through quality of that. However, it does have a very high potential, and I'll talk a little bit more about that in the conclusion part of this video, which will come up soon. And finally, here we got the 6X9PE. So this is basically, I would say, the pentode version of this triode. And of course I had it in triode mode, but it just sounded very, and this ended up high in the last test. Now, in terms of audio quality and sounding natural, it sounded very normal, very natural, a bit fuzzy really. So what it did is it seemed to really trade naturalness for a lot of decline in clarity and see-through. And so if you just want to do easy listening, it's a very nice tube. It basically, this tube reminds me of this thing, that it actually doesn't do anything wrong. So it doesn't have errors of commission, but it has errors of omissions. Like it leaves out detail, like it just, the detail level drops quite a lot, but it doesn't do anything wrong. And so this, you could also see this scale here as omitting information and not omitting information. Now, I wouldn't say this is necessarily that much less than that, but it just, I found the clarity here improves. The clarity improves here. It's just, it's not that you're really missing out. It just seems more defined in this tube if you consider the differences. Now, my final thoughts on this. These are all, I would say, on this line, are all tubes that will get you very good results. This one not. I would leave that now out. Yes, it looks fancy here. It has all the cold pins and so on. It has wide plate distance if you look at the geometry. One of the other particular types here, look at this tube, the 6S45P. Look at this geometry. It's like unbelievably solid. This is 1 millimeter steel. Anyway, the conclusion. Yes, these are all very good tubes. They're all applicable. This one has the highest headroom. These are all fairly similar. So, concluding. My advice to you. This tube I wouldn't consider no more. The E280F. So I would keep it at this. This can give you good results. Now, as your system get more, if you have very transparent speakers, I would drop out this and work with these 3 tubes. Now, if your speaker is still a little bit not super sensitive, I would probably, and you would like dynamics and detail, I would start with these 2 tubes here, the 6S3P and the 6S45P. If you like a more analog sound, a natural sounding sound, and that is your priority, I would start with the 8532W. In fact, these 2 tubes are my strong recommendations. However, they have very different optimization paths. The 8532W, because of the slight veil that I heard, what I would do here is I would use my circuitry. However, I would optimize the shit out of it in terms of quality. Use silver wiring, use the best interstates transformer, optimize all the parts, get as much clarity out of the circuit as possible, and work on that so that you sort of counteract the weakness of this, which is a slight veil in the music. So what you're doing is making the amp. Also I would work with a choke LED power supply, so work with a large choke up front, so that you make the power supply as clean as possible. That's what I would do with this tube. With this tube there was still a level of unnatural detail, so I would maybe look at maybe cap coupling this with a grid choke, make it resistor coupled, a resistor load rather than an interstage load or a choke load. Experiment with that, and work with an iron core interstage transformer maybe, just to mellow it down. And I know that is not really solving the core problem of this thing, which might be the high transconductance. Play a lot around with the operating point and the current running through it. What I find is, especially with amorphous interstage transformers, is don't be anywhere near the limits. So of the interstage, so that the interstage aspect, the material coloration that you always get with anything that you choose, it gets brought out the most if it's run near its limit. So with this tube I would actually stay away from all limits, over design everything, use high inductance interstage, or as said, use grid choke coupling, and use the best caps that you can get. Or maybe at the end, if you want to still find that this is a little bit too mechanical sounding or something, not that I found it mechanical sounding, but at the end maybe only choose some materials that offset the character of this tube if you feel in the end that you need it. With some speakers you wouldn't even need it. It will just sound perfect right out of a box, and because of the extra clarity it offsets the lack of clarity in the rest of your chain. So very different approaches for these top two tubes. Both are actually the new entries in the list, so sorry old tubes, you didn't do as well. However, I would give a special mention to this tube. I settled on 12 milliamps. Some people run it at 12, other people run it at 30 milliamps and run it hot. So there's a lot of variety here. But if you like the ultimate in dynamics, and that's the most important thing to you, or you'd like, for example, to do a full monkey circuit with your 300B or with your Type 50, that tube is very suitable. It came out high when I direct coupled it, only second to the EL33, which I found with the step-ups actually sounded nicer. So yeah, you know, use them interchangeably. I mean, you only have to change a couple of pins between the two of them. They're not pin compatible, but it's very close. It's minimal changes, so you can make these amp changes and try out other tubes quite easily. So that's my advice. That's my real top 3. I would rank them 1, 2, 3. And for that and that one way down the list. As said, there are other options, which I have put in the screen before. But that's it for my test. I hope you enjoyed. I must say I have of course moved away from this two-stage thing because it does have disadvantages, but that's not the subject of this test. This test is really for creating a two-stage amp which is simpler to optimize, reduced materials, and it's just an enduring concept that is favored by a lot of people for those very specific reasons. And also the see-through quality that you get with this type of tube is something that has its own quality. It has its own merits, regardless of having maybe a slight downside from time to time. So that's it for my test. Thank you for tuning into my channel. Thank you for subscribing. Thank you for supporting me via buying me a coffee. It's invaluable support for this channel and allows me to do tests like this. So thank you, and I hope to catch you in the next video. Until then, bye bye.